Sabko Namaskar. Very good morning to all of you. In fact, today I have not come here to give a lecture to you all or to say about what is not done and who is responsible for that. And all galaxy in front of you all, I am also not big to tell and share with you. Just you are all sparing very valuable, very important time in the context of the theme of today and yesterday's conference. Just I have one of the solution on the current problems. Just wanted to share with you and get your criticism rather than appreciation, so that whatever the shortcoming is there, I can try to improve over that. So the topic what I am going to share is on industrial and mineral waste recycling in manufacturing of composite materials, leading to create a new entrepreneurship and startup. So the material what I am talking here is, this is the material which is derived from the waste coming from different sector. Maybe at the back side of center table, these products are displayed there. Maybe during your break time, you can go through this. It speaks by itself to you. You need not even interact with me. Further, any of you would like to interact, I am available around the clock. To make this product, what is the raw material is needed, and what is the processing is done, what is the quality of this material, and where are we going to use, and what is the other future opportunities. That's what I wanted to share with you. So the main aim of my being here is, we have developed a new class of material which is not available either in India or in other part of developed countries. And since the material is developed, we wanted to go for commercialization and create many new industries and provide our S&D inputs to the society and the environment. And all of you know, either from European countries or United States, our Mother Earth is carrying almost 20 billion tons of the waste coming from different sectors, whether it is mineral industry or metallurgy industry or agro waste or biomedical waste or plastic waste or marble industries, many sources. United States, they produces about 8 billion tons of waste, and European Union, they produce about 7.5 billion tons per year. India, we produce almost 1 billion tons of the waste materials, which normally we know the garbage or the plastic waste, it is discarded in front of our eye. But apart from that, there are huge waste is discarded away from our eye on daily basis. For example, we know that for generating the electricity, the thermal power plant, they burn coal. While burning 1 ton of coal, the power plant produces half a ton of ash as a waste material. Similarly, we know the aluminum is used for many applications. But for manufacturing aluminum, the bauxite ore, the aluminum industry they use, they will have only 50% aluminum in the bauxite ore, remaining 50 is a waste material. Similarly, you take the iron ore, hematite ore, for manufacturing your steel or iron, only about 45% is coming out material and remaining almost more than 50% is a waste. Similarly, there are many other sources of waste as listed here. Among the waste, what we India produces, almost 350 million tons, they are organic in nature. And about 400 million, they are inorganic waste. And apart from that, there are hazardous waste or some other complicated, complex waste, including nuclear waste. And we are talking about that, the product, what I am going to address is one is on how are we going to recycle those waste into a product. The other challenges what we are discussing today are the rural employment, rural livelihood improvement, and rural economy. Fortunately, so I was having my work and 1 year on the glass fiber waste composite in United Kingdom, where the developed countries, they are using 100 years back the glass fiber composite either in the transport system or in toilet, bathroom, or in your kitchen. But today at the end of the life is over, it has to be disposed of the glass fiber composite. That comes under hazardous category. They have to pay even 1 kilogram, they have to pay many hundred pounds. But now the developed countries, they are working on how to utilize natural fiber as a reinforcing material in composite. So India, we produces more than 400 million tons of natural fiber. Among the jute fiber, we are the leaders in the world for jute production. Apart from that, the coconut and banana and bamboo fibers, we are the second largest producer in the world. So here, when we talk about the rural, all the natural fiber, mostly it's coming from the rural. Maybe some application they are using for making of rope, some cases, some handicraft items. So there is great opportunity to utilize the natural fiber, whether it is jute fiber, banana fiber, hemp fiber, pineapple fiber, or coconut coir, or many more, sisal fiber. In an organized way, they have not yet been fully exploited for engineering applications. There are a lot of opportunity to use those natural fibers for value addition, and that lead to create rural employment, rural economy, and rural livelihood improvement. The problem what we addressed to make this product is Government of India, they have banned the cutting of forest, deforestation. What is the alternative? Like India or Middle East, we don't have any forest reserve. Moreover, if we wanted to use the timber or teak wood, for 50 years we have to cultivate it. After 40, 50 years we can harvest and use the tea. But in developed countries, every alternative days there is a rain, and our 50 years old tree in developed countries, it is there in 20 years or 15 years. So we have a demand for alternative materials for the teak wood. If you compare the synthetic product like particle board, medium density board, or plywood, they have many problems like termite, fungus, water. So here the other issue addressed is a holistic approach for the recycling and utilization of the industrial waste and exploiting the unutilized renewable resource natural fiber, and also work out solution to the Government of India initiatives on Make in India or Clean India or Skill India missions. And finally, it leads to save our environment and leading to create a new class of material to the society and the composite industry. So I think technical aspect, I don't want to enrich here. Some of you may be already knowing it. Even you see the finer fraction of the, like face powder, the industrial waste, it look like your tennis ball or your basketball. Even some of the particulates, it used to look like your diamond. So that's what it's wanted to show. As far as the natural fibers, also I got an opportunity to work on natural fiber in New Zealand for 6 months and 1 year in the United States at Washington State University. With my exposure in 28 states in United States and many institutions, what I understand is the product what we developed. This is from, for example, from the red mud. This is from the iron ore mine tailing. And another product, this is from the fly ash. And there are many products are shown there. So basically, we can use natural fiber as a reinforcement in making of such composite. The composite material is made with 3 components. One is the natural fiber as a reinforcement. When you use RCC, you use the rod, steel rod, for reinforcement. Similarly, the composite work out in polymer composite. And the particulates coming from different industries, we can process it, we can bring to a quality to fit into the product. The polymer is used as a binder. Whatever the product you are seeing, this yellow color and the sky blue, this is the product, end product. We have provision for lab scale studies and pilot scale studies at CSIR, AMPRI, Bhopal. Whatever the sheet, what you are seeing here, it is a 2 meter length, 1 meter wide, and then we can make a different profile. This material can be used as an alternate for the timber product and synthetic materials like medium density board, particle board, and plywood. And we are targeting to achieve a quality equivalent to that of plastic. Already we have done a lot of experiment and come out with a solution that we can make a alternate for the plastic. Since the GRP product is very high strength, we are also working out how to enhance its strength equivalent to that of GRP product. This product, we can do any type of operations like nailing, healing, drilling, cutting, screwing, equivalent to that of timber product. We can make this product any corrugation profile, either for false ceiling or roofing. We can make any color, any texture, any thickness from 2 millimeter up to maybe 30 millimeter for floor tiles up to a door. We are also trying to disseminate this product at different forum. Since it is a technology, a marketable stage, it reached just 2 years back. I would rather request you all, if you are confident and seeing this product has a potential, I would like to humbly request you to act as an ambassador to transform this real product to the society or entrepreneur or industry, not only in India. It has applications all over the world. Just wanted to show a couple of parameters, how this material is having different characteristics or quality than that of the conventional product. Just you see one of the parameters, water absorption capacity. You are seeing first 3 small bar chart, RMP. R indicates red mud, that is bauxite residues from aluminum industry. The second bar chart is FPC. F indicates fly ash polymer composite, the fly ash from thermal power plant. The third one is MPC, that is marble waste particulates composite. The water absorption is less than almost 2% in terms of the product what we have made it. When you see the T coat is almost 20% absorbs the water, and then medium density board 12%. It has water absorption capacity. In terms of tensile strength, we can see the first 3 bar chart, the product what we made it is more than 20 megapascal. The remaining bar chart, RHB rice husk board, PB particle board, then extended polyester resin board, then MDF medium density board, and teak. So you can analyze yourself in terms of the other characteristics. This is a compressive strength, and this is a flexural strength. Where in terms of all impact strength, the flexural strength or compressive strength or water absorption, the product what we made using different industrial waste particulate, they are far, far better than the tea coat as well as the synthetic wood what is available in the market. We have also tested the fire behavior, and we understand that it has very good fire extinction characteristics. Once fire takes place, it won't propagate. In terms of the price, when we are comparing the tea coat, it is almost 50% cheaper. But when we compare the market particle board, MDF board, it is about 10% cheaper in the lab scale. But possibly when you go for commercial scale, it will be far cheaper. That's what I understand and learned from my industry client. And whatever even today, the modular kitchen, the board what we are using at our house, the price per square feet, it varies from 300 rupees up to 850 rupees, even 1200 rupees. Equivalent to that of the modular kitchen board, we can make this product having a price even 25 rupees to within 100 rupees. Here, one of the natural fiber, that is Sisal fiber, you may be knowing or not, I do not know, the leaf what you are seeing, that is a Sisal leaf. So this Sisal fiber is professionally in the organized sector cultivated many hundred hectares in African countries. The fiber is going to Brazil for processing it, and the processed fiber is going to Germany and United States for making an interior in your BMW and Mercedes-Benz as a fully biodegradable composite. That's why your vehicle, these two used to be always costlier than that of any other vehicle. Here in India, in organized sector, this fiber has not yet been started their utility except making rope. Normally, if you wanted in the village or in the tribal areas, it will grow in all type of agroclimatic conditions. There is no water is needed for cultivation except the initial, while breeding, the natural rain is sufficient, no maintenance needed. Traditionally, to extract the fiber, the people from tribal areas, we have seen that they cut the fiber, the leaf, they submerged into the water overnight. The next day, they used to beat on a wooden hammer to extract the fiber. We have a process know-how that one-day process will be done in 1 minute. You can extract the fiber from the leaf within 1 minute. So then we have the expertise how to cultivate it, how to harvest, how to process it, how to utilize for making a value-added product, either fancy articles, or your Barbie dolls, or your hair, or your natural product table mats, or your purses, or your curtains. Many things can be done which substantially provide input for the rural employment. That maybe your intervention is needed. And here we are also working out how to use as a fiber which is far better than that of any other natural fiber in terms of the tensile strength. When you see the tensile strength, more than 650 MPa it is having. When you are comparing the other natural fiber, about 350, maximum 450 MPa. So we have made a composite. Those composites also showed there. You can see it. So we have also a small process, lab scale studies, how to make a continuous yarn. When you are comparing any other natural fiber, the Sisal fiber is very hard fiber. Due to the very hard nature, it is not having cream properties. It won't rotate. Like shape memory materials, it will come back once you test it. Only the technology available in China to make a continuous fiber, unless until it is made a continuous thread, it can't go to textile industry. So, but the technology available to make a continuous fiber is almost your pencil size, 1 centimeter diameter, what is there. but the process we have developed to make a continuous yarn of 200 micrometer in size. Then we have used it for making of continuous yarn and textile, and from the textile we made composite. And also we can use the short fiber composite and Sisal fiber also. Unless until we reach the technology in commercial production of continuous fiber, we can use parallelly the short fiber. Well, what is the application we are going to make the composite what we made it? We can use for floor tiles, we can use for partition wall, we can use false ceiling, we can make a furnitures, and wherever we use wood, plastic or synthetic product, we can replace it. And practically we are aiming to use transport interiors, train berth panels, partition panel, door panels, even including ship and even the buses. So these are all the different advantages. It is stronger than any other wood. No termite, no fungus, no water, no other maintenance. So it is also fire resistant and cost effective materials. These are all the different demonstrated product at our institute. You are welcome, each one of you, to our institute, or you are welcome to contact us. So we will be happy to substantiate. This technology we have transformed license to one of the industry in Gujarat. They are setting up the industry. And we also licensed this technology in Bilaspur, not in Bilaspur, Bhilai in Chhattisgarh. They are setting up the industry, just 1 year is old. And we also licensed the technology at Chandrapur in Maharashtra. This industry has already set up the industry and started the production. So he is targeting just maybe of about 650 panels, maybe of 6 feet by 8 feet size, having different thickness per day operations. And he says, I will make a revolution on this product. Just give me for 4, 5 maximum years, because this is a new product. But just he started a production, he started selling it. Maybe many policyholders are here. When he started selling it, there is a GST. This was given under 28% of GST. So then he told that if 28% GST is given for your product, your technology will die. This is a waste-based, it is natural fiber-based, it has to be worked out. Then we had a meeting with the GST Council, Joint Secretary Mr. Rastogi, and who has considered, but not to zero level, but some extent, but we do not know when that time will come that it is being implemented and notified. And we are working out on how to get the BIS standard and application and approval from the Central Public Work Department. So maybe we would appreciate your intervention, how to overcome these two issues. So we can make any thickness, any size, any shape, any color, any surface finish. You want sometime wanted to painting, we can have a rough surface. You want to have glossy finish, we can make a glossy finish. And if you wanted to have a screen printing, suppose you are looking on the wall, maybe airport infrastructure like Atlantic Ocean, or you want to see a park, we can make a texture of completely the similar texture. Screen printing can be done on this. Some of the product is shown here. What you are seeing, the CSIR, SCRC, CSIR, CGGRA, and AMPRI, this is a screen printed logo. And we can also make a lightweight composite having a density of 0.3 gram per cc. And you can make a high strength the composite, maybe of the strength is directly proportional to the weight. And we can make a sandwich composite of any sandwiches. So this innovation technology is readily available for licensing and commercialization. And maybe there is a 5 minutes YouTube films also available on Google search. When you type composite, AMPRI, Bhopal, you can get this film that will give you some more ideas. So you are welcome to CSIR AMPRI for our further collaborations on the mutual benefit. So with this, I would like to just conclude by sincerely thanking the organizers for creating opportunity to share with you on these technologies. This is only one of the technology what we have readily, it is readily available. Similar to that, there is another technology is there that is called radiation shielding material. Currently, you know that the hospital, the X-ray room, the radiation shielding, they use lead partitions. You know that all the hospital, why do we need the complete packing of the X-ray room? The radiation should not come out exposed to human health. So the radiation shielding material is a lead-free material developed from the iron ore tailings, which is rich in iron and other lead and barium content. So this technology was well established. Department of Atomic Energy has already approved in the DAE website. You can see the composite developed by AMPRI Bhopal can be used for radiation shielding, not only in hospital, in nuclear power plant. Where nuclear power plant, they use shielding of radiations, RCC beam maybe of 2 feet thickness. But we can have 2 feet, 1/5 of the thickness by using the material what we developed. The technology is there. The another technology called cement-free concrete. You make a concrete, any structure, any floor, either for road or civil infrastructure. So no cement is needed. That is called a geopolymeric composite material. So without cement, using of almost about 80% and 90% your industrial waste, using of maybe 10% of some specific chemical, this material can be made geopolymer concrete. So you are welcome again to contact us for further details if you require. And I would like to sincerely once again thank you all for your kind patience. And I would like to even hear your criticism, and I would strongly expect your criticism for further advancement. Thank you all.
Thank you so much. May I request General Arun Kumar Sahni to present a small token of gratitude to our distinguished speaker. Ladies and gentlemen, we have our next technical plenary session, Price Volatility of Resources, a challenge towards minimizing and mitigating the price volatility of essential commodities. May I request Ms. Henriette, Councillor Environment, Energy, Climate Change, Delegation of the European Union to India, to come over the stage and chair the session. We are also honored to have Mr. Sanjeev Paul, Vice President, Tata Steel Limited,